Hello everyone, and welcome to CRAMSURG, Clinical Research Appraisal and Methodology for Surgical Trainees, where we pick a paper fresh from the press on a hot general surgical topic. We review it for you, we present it for you, we critique its methodology for you, and provide top-of-the-field expert opinion and teaching on research appraisal and methodology. My name is Gio Perin, and together with Professor Sababala Subramanian and Maria Digby, we bring you CRAMSURG from the wonderful region of the Yorkshire and the Humber.
Today we're going to review a few bits and bobs of statistical tests. Particularly, we're going through a quick review of parametric tests and correlations. Usual disclaimers, I'm not a statistician or an expert in stat software, but I sort of play with stat software every now and again, and I kind of enjoy reading about statistics. This is a summary of what we have done so far. So we're going to quick firing through a few of these tests using an example. We're going to focus on normally distributed data today. So almost everything here is going to be about parametric tests, as we said. And we're going to do it with Jamovi. So I'll start by briefly introducing the project that we're going to use as an example. This is something you've seen before. It's a project related to my own most recent dissertation. I looked at papers published in a number of high-flying medical and surgical journals. And after finding all the papers that they published over a period of 1 year, I looked at how they advertise such academic content on Twitter. And I looked at each of the tweets that the journals put out, and I looked at how those tweets were structured, looking at the use of visual abstract, use and types of hashtag mentions, and so on. And finally, I attempted to determine whether there is a relationship between either the publishing journal or the way the tweet was made and generated, and the number of retweets and likes that such tweets actually get. And I used a number of statistical tests to explore that relationship. So we're going to draw some examples from that, and we're going to use Jamovi to show you how such tests can be run. So let's start with question number 0. We said we're talking about parametric test. So when we're talking about parametric test, Maddie, what's the most important assumption that we need to remember?
Normality.
Yes, so when we're applying the parametric test, we need to know if the data is normal. And how do we know if our data is normal?
And that can be visually through charts or a Shapiro-Wilks test.
Yes, correct. So let's have a look at how to do that on Jamovi. So this is the data set of my dissertation. As you can see, there's quite a lot of bits and bobs there. So the simplest way to figure out, I presume you can see Jamovi and the data set?
Yeah.
So the easiest way to start is to go on Exploration tab and Descriptives. And when you're in this particular tab, you can choose a particular variable you want to look at. So, for example, we said that I was going to look at retweets and likes. So let's see all about retweets. So very quickly, when you put that on there, Jamovi will give you a brief summary of your data set. So we'll tell you how many data entries are there, how many are missing, what's the mean, what's the median, what's the standard deviation, and minimum and maximum. You can do way more than that. You can have all the quartiles you want, you can have variance, you can have interquartile range, you can have skewness and kurtosis, of which we talked about before, and you can also have a Shapiro-Wilks test. You just have to check that little one there. And a Shapiro-Wilks test will come back showing you a statistically significant result when the data is not normally distributed. That is to say that you should not use a parametric test on retweets. But because I just want to show you how to run that test, I'm still going to use the variable retweets. But we know we shouldn't use it because the data is not normally distributed. If you then want to check visually, you could use a box plot, which is one of my favorite charts. And you can see that this particular variable is so full of outliers, And you can do histograms, you can do density, you can do bar plots, you can do all sorts of stuff. You can see it here. So if you look for visualization of data and how much outliers are affecting your distribution, a box plot works pretty well. Okay, right. We will go back to the presentation for the next question. So, Mandy, are you okay to take the next question as well?
Yeah, that's fine.
Excellent. So for our question 1, we're looking at 2 groups. We're looking at medical papers versus surgical papers. That is to say, papers that were published in a medical journal, papers that were published in the surgical journals. And our outcome is going to be retweets. So in terms of variables, what do we have here?
So there's continuous variables, the retweets, and then there's 2 independent samples.
Yes, because medical papers and surgical papers are independent from each other. There is no sequence. It's not like I've tried something to make something better and then I'm testing again. These are 2 completely separate samples. They're called independent. And what parametric test that we know you could use here?
The student's t-test would be appropriate here.
Yeah. If the data were to be normally distributed, the student's t-test would be a good choice. Tricky question. Do you remember who invented it? You can say no.
No, I don't.
It was Sir William Gossett, a master brewer at Guinness. And he published it with the pseudonym of Student's Tea because he was not allowed to publish under his own name due to strict copyright laws from Guinness itself. You don't need to remember that. It's just a little curiosity. Right, so very easy to run a t-test on Jamovi. It's there. And also Jamovi tells you that what you should do is an independent sample t-test in this particular case. So as you can see, again, super easy. You get your dependent variable in there, which is, as we said, retweets. And a grouping variable, because obviously, we want retweets from some papers and from some others. And that would be, in this particular case, surgical or medical. So you just pop that there, and there you go. You've got your independent samples t-test. And as you can see, this is statistically significant. You can also, and you certainly should, run a normality test. And Jamovi will very quickly tell you that, hey, this data is not normally distributed, you're using the wrong test. He's also telling you that another assumption is violated, but we will talk about that one in a second. So I hope that's nice and simple. That's literally how you do it. Right, let's move on to the next question. Question 2. So Emily, are you okay to take this one?
Yeah, that's all right.
Fantastic. So in this case, we've got 2 groups. We are looking at papers that were advertised on Twitter only with text. So sometimes they just write the title of the paper or something like that. And then they tweeted them again, but that time with a visual abstract to try and boost the social media presence. And the outcome is retweets. So what have we got here in terms of variables and groups?
It's still continuous variables, but the samples are paired.
Yes, correct. The samples are paired because we have the same papers. They're published first as text only and then as a tweet with a visual abstract. It's kind of like testing patients a baseline when they're having their antihypertensive prescribed and then testing them after the antihypertensive. For each observation in one group, there'll be an observation in the other group. and they will be linked because they will be from the same patient. Kind of the same thing here. So what test could we do here?
Would that be a paired t-test?
Absolutely. And again, easy as pie. You just go there, paired samples t-test, and you do exactly the same thing. And you put it there. And then, obviously, because these are supposed to be paired with each other, you don't have a discriminatory group variable. So you just put both your retweets and retweets with boost in the same box. And Jamovi will run your pair samples t-test. And again, you can run a normality test, which tells you again that you shouldn't run this test. Okay, perfect. Any questions so far? Feel free to unmute and talk if you like. Otherwise, we'll just move on. To question 3. I'll go back to Maddie if Maddie's happy to take this.
Yeah, go for it.
So this time we are going to look at papers from 6 different journals, all the journals that were included in this study. And the outcome is going to be retweets. So not 2 groups, but 6 groups. What have we got here?
So that'd still be continuous variable, but independent samples and multiple groups.
Yes. So what should we do?
That would be an ANOVA.
Yes. And another tricky question. Do you remember who described ANOVA first?
I'm getting all the tricky questions today.
Guy with the tiny glasses. Fisher.
Fisher.
The same as the Fisher exact test. Very proficient statistician, and he used to work in agriculture first, and then he became a prominent figure in statistics once Carl Pearson kind of semi-retired. I don't think he ever retired. He's kind of like one of those surgeons that always come back to do a clinic or an endoscopy list or something like that, even when they're 75. Okay, so let's see how to run an ANOVA. Again, Jamovi makes it very easy. It's there. So we're going to do as a, you can do it as a one-way ANOVA or ANOVA. Practically, they do the same thing. So the dependent variable is going to be that. And our grouping variable is going to be the different journal, which is a journal title. Boom. There you go. And there you got your one-way ANOVA. As you can see here, Jamovi has already done some corrections. So we are working on parametric tests with equal variances. So we should use the Fisher one, if that makes sense. If the variances, if there is heteroscedasticity, which we mentioned in a few slides, we should not use Fisher's, we should use Welch. And, we'll do this again when we do the Welch one. So one-way ANOVA, super easy to run. And you can also get descriptive tables and plots, homogeneity, normality, and QQ plot. So you can get group descriptive, so it will tell you exactly where the way of the difference is, which is also quite good. Excellent. Right. So question 4, papers from different journals. Maddie, do you want to take this one as well? Although I pretty much gave you the answer already. This time we're looking at likes, not retweets. But in this case, the Levin's test as a p-value of less than 0.001. So will you remind me what the Levin's test is?
The Levin's test is a test of homogeneity of the variances of different groups.
Yes, that's absolutely correct. He looks at variances within different groups. The vast majority of tests, like ANOVA, for example, Fisher's ANOVA, they do assume that the variance between the different groups is similar. Doesn't have to be identical, but similar. That's called homoscedasticity. When there isn't homoscedasticity, you should not use Fisher's ANOVA. You should use something else. So we are in the same situation as before, pretty much. But this time, what should we use then?
That'd be Welch's ANOVA because the variances aren't homogeneous.
Yes, correct. And we just saw how to do it. So you do it the same way as you do Fisher's ANOVA. You go on one way, and then instead of assume equal variances, you do don't assume equal, and it will give you the Welch's one. You still have to respect the assumption of normality. So Welch's ANOVA can get past the variances differences, but it's still a parametric test, if that makes sense. Excellent. And quick one, we're nearly at the end. We're asking ourselves, are likes and retweets correlated? Well, you would think so, wouldn't you? Because, you know, if a tweet is successful, both retweets and likes should go up. And let's say that we're asking our questions with normal data. So, Emily, what type of correlation test do you know that we could use in this particular case?
Would it be Pearson's correlation?
Yeah, absolutely. Pearson's correlation is probably the first one that sort of was described, although it was not described necessarily by Pearson. And it does work well when the data is normally distributed. It doesn't if it isn't. Quick question. Does Pearson, a statistically significant Pearson's correlation coefficient prove causation?
No.
No, absolutely not. Absolutely not. It doesn't prove causation. It just suggests that there is a link. It's not like likes are causing retweets or retweets are causing likes. In this particular case, it would be the quality of the tweet or the paper to cause both, but they might well be correlated. So let's see how to run this in Jamovi. Again, super easy. You go on regression, you do correlation matrix, and you pop in retweets and likes. And there you have it. You've got your Pearson's correlation coefficient, which is nearly 1, which suggests an almost absolute positive correlation and a statistically significant result. You can even have a correlation matrix, which will give you this beautiful plot, which again shows you how when one rises, the other one does as well. Bam, 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 bam. Super easy. You can also, if you really want to, for example, you're writing a paper, you can have your asterisks put there automatically by Jamovi and even a confidence interval. So yeah, that's super easy. And I think we are heading towards the last question. Emily, do you want to take this one as well? Is that all right?
Yeah, that's fine.
So we are in the exact same situation as before. But in this particular case, we have not normal data. So data that is abnormally distributed. If this is the case, what type of correlation should we use?
That'd be a Spearman's correlation.
Yes, correct. And we said this multiple times today, but what test should we use to check for normality?
The Shapiro-Wilks test.
Absolutely, absolutely. And by any chance, do you remember what trick Spearman used to get around the issue he had with not normally distributed data?
Yeah, it ranks the numbers instead of just using the raw values.
Absolutely. Ranking makes often a distribution that is not normal look much more normal, and ranking variables across your two groups allow you to then run a correlation coefficient even in absence of normality. And again, that's super easy to do in Jamovi. You go again on regression, correlation matrix, and all you have to do is just check Spearman instead of Pearson. There you go. There's also candles there, which is what we talked about not last time, but the time before. That episode will be up and running soon as I get time to publish it. Excellent. I think this is over. Sorry, I kept you for a whooping 20 minutes. So thank you very much for that.
Thank you everyone for tuning in and listening. Until next time, keep running your life with our surgical